Good morning, everyone. My name is Jason from DK1B with registration number of 0520F2030. Today, I'm going to present my slide, which is compressive strength test cube. So, what is compressive strength? Compressive strength is the capacity of a material or a structure to resist or withstand the compression or the force. Or another word is a load. Basically, an example like the building, like high-rise building, right? So they build the building. They must also calculate the load they're gonna be applied onto the ground floor as they are building the building itself. So okay, so this is what compressive strength is. So what is compressive strength test cube? Compressive strength test cube are used to see what ratio are perfect, to see what how long does it take, because um, how long does it take for the concrete to cure, how much strength does it have after a certain amount of curing. And so today we're gonna go straight into the theory of it. Concrete cube are made on site to check the strength of the concrete is above the minimum strength which has been specified, because as we know, building stuff, something like a highway or building a building itself, you have to know the weight that it's gonna have on those legs of the building. Okay, so this is the theory of it, is to measure the axial compressive strength of the concrete cube, which are made, cured, and tested to a very specific requirement. Each building has their very own requirement, so you must know those requirements of them. It does not measure or predict in any unique way the strength of the concrete in the structure. The test is simply a quality control test which measures the consistency of the concrete in terms of one particular property, compressive strength, using an arbitrary test method, testing the same concrete under different conditions, for example, specimen size, specimen shape, curing temperature, loading rate, etc. will give different results, such as we are using different type of aggregate, right? And then continuing, casting, curing, and testing cure should be carried out in the correct manner. Even small deviation from the standard procedure will usually lead to compressive strength results which are lower than the true strength of the concrete. For example, like for each 1% air interrupted, there will be a 4 to 5% of loss of strength, because if you if the concrete cube by itself has many void or many empty space inside it, it will causes the strength of the concrete cube itself to lower by a lot. Even it's shown here as even as 1% of air could causes 4 to 5% of the concrete cube to cease, to not be there. So the strength of the concrete is not fully there at all. Now we're gonna look at the material and the apparatus that are being used. And I couldn't really show a video in this slide due to I didn't find any. I didn't have any virtual lab equipment and apps or exe file, because due to my storage in my laptop is very limited. So yeah, so now we're gonna look at the material and apparatus that are being used. So we start from the material, which is the cement, sand, granite, tap water, grease. The reason, as you guys can see, we got sand, which is fine aggregate, and granite is coarse aggregate. We can do multiple type of compressive strength tests, like for example use each kind of it, or like for example the first first cube has only sand in it. The second cube has only the coarse aggregate or the granite, and the third one has mix of both, which is sand and granite in that mixture. Of course, in all three of them have the cement in it. So what's the use of grease wall is it is used to making sure that the concrete itself doesn't actually stick to the block. Okay, so now we're gonna look at the apparatus that being used. We get compressive testing machine, sampling tray for the concrete mixing, a shovel, a scoop or a trowel, steel float, compacting bar, standard cube mount that goes by 150 millimeter by 150 millimeter. Weighing balance brush is used to apply grease onto the mold, and spanner to tighten the bolt around the mold. Alright, so this is the procedure, which is the first one is the proportion of the ready mixed concrete are prepared, with the material required are calculated. The material of each cube is mixed separately according to the ratio, using the concrete mixture ratio of 1:4 and 1:6. All inner surface standard mold is wiped by grease oil using brush. The concrete mixture with 3 layers of approximately 50 millimeter each. Every layer is compacted by using compacting bar not less than 35 strokes per layer. Compaction are done in a uniform manner over the cross section of the mold. The top of the mold level is moved with the steel float, and the procedure are repeated for another 2 more. The specimen is demold after storing in a vibration-free place and in conditions that prevent loss of moisture for 24 hours. The specimen immediately submerged in water at the 227 more or less 2 degrees Celsius in water tank. Cube will be tested on day 7 and day 28 after the submerge. Before immersing all cube have their weight taken and will be stated as M1. And once again on the test day, the cube will have the weight taken and stated as M2. All testing machine bearing surface are ensured to wipe clean, and any loose grit or extraneous material is removed from the surface of the cube, which will be in contact with the platine or plate of the mold itself. The cube is carefully centered on the lower platen, and the load are ensured will be applied to both opposite cast face of the cube. The cube is put on the bottom of the plate of compression machine, and the bottom and upper plate were made to ensure to touch the cube by releasing load valve. Without shock, the load is applying and increasing continuously at a nominal rate within the range of 0.22 Newton to 0.4 Newton until no greater load can be sustained. Due to the constant application of the load, the specimen will start cracking at a point and finally break down. Those are noted, and the maximum load that applied to the cube are recorded. The procedure are repeated for another 2 cubes on 14 and 28 days. The compressive strength of the specimen can be calculated by dividing maximum load carried by the specimen by cross-section area of the specimen cube. Express the result to the nearest 0.5 Newton millimeter square. This is the result. On the left side, we can see an image of a type of cube failure that we would get. It's different on what type of aggregate that we use. For example, like coarse aggregate, we're of course gonna see the explosive failure. If we have a fine aggregate, we're probably gonna see a same result as explosive failure. But if we have the mixture of fine and coarse aggregate, we're gonna see the middle one, which is the side chip off. Okay, so in the middle we got the graph. On the far right we got the the table that calculate the compression strength and the max load that it had. And with that, thank you for listening and done.